GM, guys. I think we're live. Hi, everyone. Hi, everyone from everywhere you're joining from. Good morning, good evening, good afternoon. Really excited to have you all here again this week. Welcome to this week's Fireside Dev Hang. My name is Idris Olubisi, and I'm really interested. I'm really excited to have you all here. I am a developer educator on the DevRel team at Midnight Foundation. If we are meeting for the first time, welcome once again. If you are joining again, yes, welcome back. So it's great to have you all here today. We have got a packed session with updates, insights, and some community highlights you won't want to miss. So I'll be going through a couple of things I will be doing today. And then the first, I'll be highlighting like recent wins from our contributor hub and then sharing update on upcoming content bounties. So if you are looking to contribute and get rewarded, stick around for this. I'm going to share all of these details and also where you can find them. Then Steph will walk us through the latest validator updates and our environment roadmap. So you know exactly where things are headed. And then after that, we are diving into the recent survey results where we show you some feedback and also how this is also helping us to, shape what we build next. Then finally, I'll pass it to Jay. Jay will then give us an update about the game jam update. I know like game devs are excited about this. So you learn everything with the latest progress and highlights. And then we have got a special community spotlight presentation from NoC. And after that, I think that's the final presentation that we'll be having today. So quick reminder, if you are not already on Zilli board, head over to zilli.io/cw/midnight network. I think you see a QR code on the screen right now for the Zilli. So you can start any point for your contribution. So, all right, let's get right into it. All right, so yeah, the Zilli Quest QR code is up right now. If you want to scan, you can scan. Make sure you scan, you get connected, you set up your wallet, set up your profile, and claim point as much as you can. So the first thing first I want to talk about is what exactly is happening in the contributor hub, and also what are the changes coming up in the next few weeks. So if you haven't seen this before, if this is your first time, this is what the contributor board looks like. And we have some really interesting ideas that you can take a look at. So first, you would see we have different tracker, different status. We have the no status, which is like just the beginning stage, the idea backlog. And then we have the ones that are currently in progress. We have the ones that need discussion, probably feedback from the community and that needs to be done. I would also see the ones that have been completed. So this is a board that we expect every one of us to be a part of and also check constantly. So if you scroll down, one thing I want to highlight here is that if you scroll down here, we have a lot of ideas on some of the things that you can try yourself and some of the things that you can experiment with basically. And then one interesting thing also is that you can go into a particular issue. If you find it interesting, you can thumbs up, like you can react to that issue. If you want it, you can upvote, you can do things so that it then brings visibility to that particular issue. Sometimes you feel the need to cover all of the breadth and things that you need to know about the issue, but we've also seen that if you have plans that you want to execute or probably implement this particular feature, then what you need to do is to get started and indicate. Then we can then support you. These things, all of the ideas that we have here requires a lot. It requires research phase, it requires implementation stage, and then you also require like the actual execution stage. So we don't expect you to just start from building out a full-blown app, but if you have any idea and you have ways or you've been thinking about it, you should spend some time researching, and then you can then assign this issue or like request for assignment and ask questions. Then we'll be happy to help. So this is for the contributor hub. We also have an ongoing, let me quickly navigate there. So we launched the bounty program about, I think it's over a month now. And then if you go to the contributor hub issues and then you filter by, let's say, the bounty label, you should see all of the bounties that we currently have open. You can see we've closed some have already been implemented that we've merged, and some is already also currently like in progress. So we encourage you, if you haven't seen this before, please go through and self-assign. By the way, we are going to relaunch even more, like add more issues here, and also relaunch some of the existing ones here that is yet to be completed. We'll be sharing the details in the next few weeks, and these details would include how you can apply, how you can be a part of it, how you can contribute, what also is the reward process, the submission process, the review process. You see basically everything you need to know about the bounty program. This particular round that we have currently mostly focused on us experimenting what needs to be done or what you could benefit from this particular bounty program. So, but then it doesn't stop here. This is particularly around content bounty, videos, tutorial, hands-on. We have really, really cool ones coming up, and then when we announce the page, we will definitely let you know. Bounty programs like the game bounty, we will also have bug bounty at some point, so you guys should wait for that in case you want to like find bug and you want to learn more about the Midnight ecosystem, the protocol itself, and you want to contribute. We have that coming up as soon as possible. So if you have any question, please feel free to ask. I'll be happy to answer all your questions. You can always reach out, but if you are joining us, you are here right now, you can ask and then I'll answer them. But I just want to highlight this so you know where to find those issues, you know how to request. We've announced this previously, so you can read more about the details on how to get started. So we've also had so many recent wins. If you check the closed PR, you see that we've made a few. Big shout out to the contributors making like that contributed this into, I think, the docs. We are really, really grateful and we are happy to continue working with you all. And these are exactly the kind of contribution that help the ecosystem grow and also make Midnight more accessible to developers everywhere. Big thanks to everyone who has been putting in the work. We really, really appreciate. So if you haven't jumped in yet, this is your chance to jump in before we relaunch the second round and would announce publicly for everyone to be a part of. Now, all right, so that's the rundown on the community hub and bounty program. If there's any question, I'm happy to answer them. I will be handing over to Steph to walk us through validator update and environment roadmap. Steph, take it away.
All right, thank you, Idris. So hello everyone. I'm Stev. I do DevRel at the foundation. For those that maybe if you've seen me for the first time, also in Discord under Stev. I'm mostly active in the Block Producers channel, where we have all our wonderful SPOs and validators who've been with us for quite a while, actually. But I'm going to talk about some of the stuff. Some of the stuff I kind of hinted about in the previous Fireside, and some stuff I'm actively talking about too with SPOs in Discord. But there's a blog post finally on the Dev Diaries on the documentation website. It's titled Testnet 02 Transition and the Roadmap to Mahalo. So I think we could put a QR code for that blog post on the screen if you want to go ahead and read it. But this is the latest update as it pertains to validators. It gives a bit of an overview of the environment roadmap ahead. So right now we actually, I'd say testnet was a pretty monumental success. I mean, it has been a testnet, and we fixed things, people broke things. It's been an amazing journey, and the amount of growth and deployments on it is pretty incredible for a project that's in this phase. But also, as far as SPOs, we have like over 180 I hate to say 180, it might be 200 now, but Cardano stake pool operators who actively participated in the testnet, which was pretty incredible. We have people using community tools, helping each other out, and it's been a big great success, and we listen to some feedback, and part of this update is to basically talk about what's next, because testnet 02, that environment is actually going to be sunset in end of February. Now, we were initially told Cardano stake pool operators, like, hey, you'll migrate to preview, but we kind of made a bit of a strategic pivot in order to reach the next milestone. So, and just to give you an overview of those milestones, it's in the blog post, but we basically have Hilo, which happened in Q4 of last year. That was, the night token Genesis. And then we also have Kukulu coming up, which is the federated mainnet. It's coming quite soon. And one of the dependencies for that is the federated testnet, which is currently underway. So that's basically what's happening right now. And with preview, because preview is supposed to be more experimental development, then we have pre-prod, which should be the federated mainnet, and then federated mainnet, at least in the near term. So in order to reach Kukulu, we really need core engineering really needs preview to undergo rapid iterations, rapid deployments, and rapid testing. Just given our ambitious timeline. So SPOs will have to wait for Muhalu, which would be the incentivized mainnet. And I'm actually happy. In a way, I'm kind of happy we're doing this, because it kind of goes into some of the survey results, because we listened to your feedback. Some of the things absolutely, you guys were absolutely spot on with some of your feedback. But in the meantime, SPOs you're absolutely welcome to participate on testnet 02 if you want to. Otherwise, you're not required to migrate to preview. And I'll be say stay tuned for Mahulu, and you definitely want to subscribe to the Midnight Validator Digest newsletter, because that's where we will put a bunch of communications in there. And at scale, when we have IT and other things, that digest will be a critical piece of communication infrastructure to get news and updates to you. So I definitely want to make sure you subscribe to that. I think we have a QR code we might be able to put for that, for the Midnight Validator Digest. So I want to encourage everyone to subscribe to that. Well, especially if you're an SPO. And in the meantime, so, hey, I can't move to preview. What do I do now? Obviously, subscribe to the digest, and the current validator documentation is going to be unpublished, because it's been quickly outdated, actually, as of today with the latest node version. And since you're not being asked to migrate, there's really no reason to be an SPO on preview or pre-prod, since that's closed for you. So we're going to just unpublish that validator section just to reduce confusion or frustration. And we're also acting on some direct feedback already for you guys. So I know a lot of people have been frustrated with the Docker distributions and images and giving things all in like Docker stuff. And right now, Midnight Node is being released as a binary. The current latest one is a binary. And we're taking this approach quite seriously for now on. So when the documentation does come back online, it's all going to be binary and source first. Because at the end of the day, just like some of the partners you interact with, including the community, everyone's kind of like, give me the binary and I'll figure it out, or give me the source and I'll figure it out. Because according to a survey, a lot of you guys are actually OGs in Cardano and have been running services and stuff. So you guys know what you're doing. You just need, so we got to give what you want, which is, binary first and source distribution. And people want to evangelize that into superset things, that's great. Also, we removed the registration wizard, I believe, as of node 20. So registration has been registering as a validator. It was quite an intuitive process. Some of the commands were not really could have been probably better explained and other things, but we just removed this wizard entirely. And in order to register now, there's like this smart contracts part. There's this smart contracts command with the Midnight node to interact with the contracts even more directly, which we're going to evangelize in the lead up to Mahalo. And other things is, so when we restructure the documentation, everything will be binary and source distribution for first. And then and that we'll also be doing that with regular Midnight node stuff, because maybe you can't be a validator, people are still going to need to run nodes, so we're going to switch that all to binary and source, evangelizing all that through binary and source. Other things. All right, so another thing is I'd like to actually show you guys some of the survey results. If we have time for me to, I'll try to go over quite quickly. So there's a survey here. It's on the QR code. We already have over 42 responses. I created a summary out of this, and I'd love to just briefly go over with you because I don't want to take too much time from all of us. But I think it's important to, as a foundation and even DevRel, you give feedback and stuff. Everyone completes forms and surveys, and in my opinion, you should be the viewer of the results for those things too. That's not just an R thing. This is an ecosystem thing. So these are metrics and KPIs that should matter to all of us. So that's why I would love to share this as well. So I'm gonna share a window. Maybe we can share it on the screen as well. So I did a screen share, and I think it should pop up for y'all here. Cool. So this was pretty amazing survey, and if you want to contribute to it more, and give your feedback, your results will impact this form live. But what's really interesting is this was tailored to Midnight validators in particular, and we had over 42 unique responses. What was really interesting is we call this an NPS score. So how many people actually recommend Midnight? And surprisingly, we have, having 2/3 is great, but we need to do better in that. And a lot of that's attributed to, out-of-date documentation. Oh, I have to use Docker, and it's really finicky. And the Midnight node repo that you use to compose things changes so quickly. So as far as how you felt, you're absolutely right. And that's why we're taking some of the actions I mentioned previously. But next time we send this out, we hope we can have our validator ecosystem more satisfied. As far as people participating as validators, this was pretty awesome because a lot of you guys are Cardano ITN OGs. So of course they're like, give me the damn binary and I'll figure it out. So or etc. So that's pretty awesome. So it's a great privilege as a Cardano partner chain to have so many of the validators participating be the OGs from that ecosystem, which is awesome. And a lot of experience operators. So that's awesome. And obviously a lot of people are individualists, which is also great too, because a lot of individual operators encourages decentralization in any network. As far as onboarding friction, we can do a lot better in the registration, as I kind of mentioned earlier. So this is like kind of we actually have a minority of people that actually find it easy. So how can we make it easy? How can we get to more of a one-click deploy? How can we create more consistent scriptability? That's something we need to get to. I thought this one was incredible. So I'm sorry, I don't remember your GitHub alias, but y'all know who made Midnight Live View. This is just a community tool. It kind of emulates G Live View that many of us have used with the Guild Operators Toolkit, which is awesome. So we actually see a large amount of folks using community-built tooling. So that's awesome. We want to champion the success. We want to champion these tools more often. And if you do SPO tooling, come to us, ask us like, hey, we want to have Midnight features too. It'll be really cool to have infrastructure tooling or empower existing infrastructure tooling to support Midnight. But as far as some of the conclusions, some of the things I kind of mentioned, we're trying to take that binary first approach. We need to improve the registration. We're doing a radical documentation refresh. And we also need to scale our support because sometimes I'm not accessible. So I have my head down a lot with some other things right now, but I come in Discord, talked with you all, said, hey, this and that. Sometimes core engineering comes in, but you guys deserve a lot more support. So in the lead up to Mahalo, we're trying to take that more seriously to scale that. And that's kind of it I have for y'all. So if you have any questions, ask them now. Otherwise, the next person will take the stage.
All right. Thank you so much, Steph. I was reading through the comments. I was trying to see if there's any question or not. So somebody asked about the academy program, stating when Mint is going to be live. Yes. So the plan is for us to have the Mint button enabled when we are live on Mainnet so that you guys can mint directly on Mainnet. And also, I forgot to share earlier on. I think we've got some feedback regarding not being able to connect Cardano wallet, or there's this other wallet too. I'm happy to share with you all that is now possible. So if you go back to the Midnight Academy and click on the Connect Wallet button, you will be able to see the Cardano wallet option for you to select. So for the Mint button is going to be live when we are live on Mainnet. That's the plan. We don't want to give you a Mint option on testnet or preport for now. We want on mainnet so that you can mint it. By the way, we have like beautiful NFTs also that you can mint directly on mainnet. All of those things are coming soon. I don't want to reveal too much details for now, and then we'll be rolling it out like week in, week out for you to know where we are and then what is coming up next. So let me see if we have any other question. Okay. Ireland Ghost. Okay, Stephen A said, I built it too, never pushed it. I decided to wait to prepod. No worries. We are aware and we are working really, really hard to make sure that prepod is ready. And also, if you are encountering any issues with Midnight local network, or obviously the testnet is not supported right now, we are aware of all of these issues and we will definitely make sure that once we have updates, we'll share with the community and you all can experiment with things. Right. Thank you once again. So now I think that's it. Jay has something special for us. So please go ahead. You have the floor.
Thank you, Idris. Can you hear me?
Loud and clear. Yes.
Awesome. It's always great to be on here to talk to the community. My name is Jay. If I haven't met you yet, I'm sure you've either seen me on the Discord or on Twitter. I typically go by Jay Albert online. So it's nice to meet you all and talk to you. And we also had an awesome space last night. So if you were on there, it was cool to talk to you. So today, what I wanted to talk to you all about is our Global Game Jam participation. So if you're not familiar with the Global Game Jam, it's an event that happens every single year all around the world. You can find a chapter that's springing up in your local university, your local communities, and it's a great opportunity for us to all come together and make video games. It's not specific to our Web3 space or crypto. It's for game developers in general, people who use Unity, Unreal, who are posting games on itch.io, indie developers to big name studios. So it's a great opportunity for you to meet other developers in your local communities and also people online. So we decided to spring up a page, and we have a channel for this specifically. So if you haven't already, click on that QR code, and that'll allow you to sign up to our jam site. So if you can see on the right-hand side, we have about 10 different jammers that have signed up and will be entering our Discord space. So if you see some new faces, some from the game area, just say hi, let them know what Midnight is about, and see if you can collaborate with them over games. So go to this link, sign up if you want to submit a game and participate in the Global Game Jam. If you go over to our Discord channel, you'll see a channel now labeled GGJ 2026. That's where you can hop in, collaborate with other game jammers, find a team, ideate, and the official game jam will be kicking off this Friday, 5 p.m., and it will be concluding on Sunday at 5 p.m. So hop into the channel, get to meet some of your other jammers, and start pitching some ideas. The other thing I wanted to share with you is that we've also created a sprint and some quests on Zealy. So now if you go down to the bottom of our Zealy board, you can see this section called Game Jamming. There you can get some points for joining into the channel, for submitting updates to your game, and for sharing it on Twitter. So I'm excited to see all of you build out your games. We've already seen some of the teams working on tools that are pretty interesting. I'd love to coordinate with those teams, share those tools with you all so we can make game development easier on Midnight. So I just wanted to bring that all to your attention so that you know of the work that we have coming up. That game sprint will be open for a while because we intend on adding some more quests related to games, and we hope to see you all build some cool games on Midnight. So that's all I had to share with you all. Let me know if you have any questions. Feel free to post them.
Yes, let's go. I'm really, really excited. Like, this is an interesting opportunity for you to be a part of, the gaming ecosystem, the gaming community. As Jay mentioned, please feel free to check out the GGJ 26, right? The channel on Discord. You will see other, gamers, other people that you can collaborate with. If you have any ideas and you think you need a team to build it out, or if you have a question, we are happy to also support. Please feel free to make sure you make good use of this opportunity to join the Global Game Jam 2026. So thank you so much, Jay. And now I think, do we have any question?
So I do see one question in the chat. It says, glad to see some Midnight game dev collaboration. Just to clarify, there are no Midnight Hackathon prizes for the Midnight site of the Global Game Jam, right? So in general, there are no prizes offered to hack jammers for the Global Game Jam, whether you're joining our site or another site. It's just an opportunity for you to collaborate with other game developers. I will say that some of the sponsors do look at the games submitted within the Global Game Jam. So DigitalOcean, I think Exola is one of the sponsors. They look at the games that are being proposed, and if they find something interesting, they do reach out and do invest in some of those games. So that is an opportunity. But as far as prizes and the standard kind of hackathon route, there are no prizes there. We typically do reward participation in Zealy, so that's kind of separate from the game jam. And of course, we have a sprint that's ongoing, so there's opportunities to accrue points there. But there is no outright prize for this. I will say, as we go closer to mainnet, we want to support teams deploying, whether you're deploying a financial dApp or a video game, we want to support you. So we will be coming up with more opportunities to support your development.
Yes, thank you so much. Thank you. I hope that answers your question and that clarifies your concern. I'm not sure we have any other question. Thank you so much once again, Jay. Now for something special, we have a community spotlight presentation from Nosi. Nosi, how are you doing today? You have the floor.
Hello, guys. Glad to be here. Glad to be here, guys. So Vladimir from Nosi. I'm the founder, co-founder, let's say, of the Nosi ecosystem. We're currently building a fully integrated decentralized financial application on Midnight. So we're building a DEX, we've built a wallet, we're building an Explorer, we're building a Launchpad. So basically everything that some guys might actually want. And today I'm going to talk about basically concurrency in relationship with Midnight, because that has been the bane of some guys, some less experienced developers while Midnight, because concurrency in the usual asynchronous sense of programming is not the same as on-chain concurrency. So this is what I'm going to talk about. Let me also share my screen because I have a short presentation that might actually be easier to understand. Okay.
Yes, let's go.
Let's go. Wait a second. Okay. Let me also go full screen with this one. Okay. Can I see the presentation? Is it fine?
Yes.
I guess. Wonderful. Okay, so building Midnight contracts with concurrency in mind, practical patterns, simple mental models, and real test results. We have a short agenda, so basically what we're going to talk about in this presentation, what Midnight is, what concurrency means here, the simple rules, data structures, their behavior, concrete compact examples. I guess for the builders on Midnight, compact is a usual word, but for the non-technical people, compact is a programming language in which Midnight smart contracts are written. I have a small section for design patterns on Dexes, and basically some conclusions, how we tested, and takeaways and checklists. Okay, so Midnight in 90 seconds. In plain English, Midnight lets you prove things that are true without revealing all the details. Technical explanation for this: each contract has basically a ledger state, which is public, which is on-chain, which can be decoded. We're reading every block of the blockchain. Circuits, which are zero-knowledge proofs, which basically are an execution of the code in a smart contract, which is basically hidden from the public view, so you're not aware of what's happening. And witnesses, which are off-chain data from the user, which gets inserted into a smart contract. So it's not something which is deployed, and it can be customized depending on each execution, each deployment, each joining of the contract. So this is basically a short description for Midnight. What concurrency means here? So in plain English, this is how I want to explain it. Can many users do the same action at the same time without failures? And what does it mean, the same action at the same time? Basically, when a block in a Midnight is executed, can multiple users do the same action on the same smart contract at the same time without having weird behaviors, with basically everything going through? So that's what concurrency means in terms of Midnight. In a technical way, basically, multiple proofs are created from the same state and are submitted together. What does this mean? If the state changes, that means validates the proof. The proof basically means the verifier of the transaction, basically the part that stays hidden. And that means that some transaction will fail directly. They will not be propagated to the chain, they will not be submitted, and they will not be executed. If not, all transactions can succeed in the same block. So basically, if you're conscious of what you're doing, everything can be submitted in the same block, even sequential against the same smart contract. So as a mental model, what do developers in Midnight actually need to consider? So basically, you have your usual read-write operations. So when you're reading something, that means you expect a specific state value, the state value basically of the smart contract. If the state changes before your execution, that means your proof fails. What does this mean actually? So if someone executed inside of the contract block a contract call before you that mutated the state, that means your proof will fail and his will go through. So only his will actually be going. Write only, that means no expectation. all writes can succeed. The final value depends on the block order. So basically when the same slot is written. So yeah, and those get updated in the Merkle tree, depending on the way they went through. So when you are looking into any Explorer and you see like the Merkle tree order there, you see like, for example, a transaction ran from Merkle tree 120 to, that means it has done 8 nodes inside of it. So those go sequentially. It's an order tree. So yeah, if you've done in university graphs and so on, that's pretty much it. So the golden rules from our tests, the real test. I'm going also to share contract testing later on. We can see how we did this. Basically, in the same slot, if you do a read and a write operation, only one succeeds because it serializes the state of that doesn't have an exception. After you've done that, you know you've locked it for one contract call per one block. So that means you cannot have more than one execution every 6 seconds for that particular workflow. Write only. Basically, write only is that it says you can do however many writes you want. It's concurrent. It flows through. There's no problem with that, but you must be aware that, yeah, this works. Map set. So this is where things are actually interesting. Midnight Compact programming language has the usual data structures that you see in Java, in C# and so on and so forth, even TypeScript, I guess. You have maps and sets. These are basically per key concurrent. So different keys means different concurrency. And it allows you to actually read and write, so that's totally fine if it's a different key. In Midnight, we have another data structure, which is counter. Is basically counting how many executions have been done. You can increase it, you can read its current value. So yeah, that's a good thing. The Merkle tree auto-serializes, so that means it's auto-serializing, and that means you can only do it once per block, so that's locked. And other than this, we have another variant for the Merkle tree, which is the historic Merkle tree, and this allows concurrency every time it works, and that's fine. Idris and Jay, if you have any questions, feel free to interrupt me.
Yeah, sure. No questions for now. I think you're good.
Yeah, perfect. So Midnight has privacy by default, and why disclosure matters. In plain English, you must explicitly say when something becomes public. So by default, the ledgers are basically public, but when you're sending something into your contract call, you must explicitly disclose it, so it goes fine. And basically, that means in the compact rule, any value that might be witness data must be wrapped in a disclose. So basically, your secret balance, something like is the attribute where you call the contract with, must be disclosed. So this is a practical example. You have your secret balance, and you disclose it, and then you use it in your contract call as balance. Okay, and this is basically the the result of our extensive testing. So this is like a cheat sheet for everyone that develops in Midnight. So we have different ledger types, which are the data structures I talked about. We have counters, sets, maps, Merkle trees, and historic Merkle trees. Basically, yeah, developers just screenshot this. We're also going to give you the presentation later on in the test data if you want to go through it, but this is the gist of it. So counter reads the reads and serializes, as I told before. So basically, this is not concurrent because it's a read operation. Counter increment only writes, so that means it's concurrent. It's write only. Set member, which is basically retrieving the data from the set. Is this concurrent? Per key. So that means if you retrieve set A, it's concurrent. But if you retrieve set A again in the contract call, that means it's not concurrent. It serializes the same key, so that's no good. Set insert, which is basically a write operation, it's concurrent. Map lookup is the same as set member. Map insert is the same as set insert. So these are usual. Merkle tree, you can insert hash. This is the native method of it. It implicitly reads the state. So because it reads how the Merkle trees are, so that means it's not concurrent. It does that by default. It auto indexes. So if you're calling insert hash, be aware that any other person that calls your contract will only be able to do it once per block. And this is where you have a concurrent variant, which is historic Merkle tree. It reads, yes, but it's also concurrent. So this is basically what you want to use. So yeah. Here we also have a small note, which is that historic proof enables still proofs. So that means if you proved a transaction behind, you can actually still send it through. So yeah. Wait a second, I'm also reading a small note. Okay. Yeah, so here, good practices and bad practices for counter. For example, a bad practice is that you read the counter and then you write against it. This seems logical when you're basically doing the usual programming, but in Midnight, you must know that by doing this, you lock the contract call. It will not be concurrent, so you must be aware of that. So this is an example that you're reading a next ID in an incremental. You maybe want to see how many executions have been done. Depending on your workflow, you read it, okay, you have it, but then if you increment it and you have the next ID, it's blocked, so it's synchronous. And here is how you actually do this in context of, let's say, a DEX. You have a circuit which creates an order, but the order must be given as a parameter. So basically, this is how you do it. You insert it at the ID with a disclose. So you're basically, making it asynchronous. So yeah, as the plain English says, don't ask the counter for a number in hot paths. So that's this. Stats only, total trace increment. One as UID, unsigned integer of 16, write only. So if you want it for configuration for stats, that's pretty much where I'd use counter in Midnight programming. Yeah, so this is a note. Yeah, counter as unsigned integer 64. That means counter read and counter plus equals and count increment. This is how it does. Well, how can we isolate the map and set? You must basically isolate it per key. So this is totally okay to do. So for example, if you're asserting that it doesn't have this and you're inserting it, this works. It's per key. It will always work. So this is a hot path programming. So if you're running even in games, so for example, you have a card game and you must have it in maps and everyone should call it while running in the same period of 6-second execution, it must be done like this. This is how it should be. Yeah, so basically 2 people touching the same key serialize it and it's no good. And here is another interesting example. So we have Merkle trees versus historic Merkle trees. So we have the standard the standard Merkle tree. This always serializes it. So while you're inserting the hash, be aware that it's basically blocking it. And historic Merkle tree, it's concurrent. So yeah. Historic roots basically let slightly old proofs still pass. I think it's 2 hour. So basically you have a proof that is 2 hour old, it will still pass, and that's good. So that creates you and enables you a small window of opportunity. So yeah, why this works, each insert creates a new root, standard tree accepts only the current root, historic tree accepts recent roots. So this is the difference. And result, many users can prove against the same earlier root and still succeed. Yeah, and here are some conclusions from my side. DEX reality check what forces align today. From current DEX patterns, next order and next field serialize, only one succeeds. So basically you're creating the next order, you're creating the next field, and that serializes. Merkle tree insert hash serializes, only one succeeds. Map set concurrent per key. So hot operations must avoid counter reads plus auto-indexing trees. DEX fixes that unlock concurrency. This is more as a discussion. This will take a bit to actually implement. So we'll not be working directly with, this is more advanced. So basically, instead of creating the usual ledgers, you will not basically do that. You're going to work with nullifiers, and you're going to store these inside maps and sets. This is more of a smart contract hacky way to actually do it. You're assigning the coins, the tokens to a contract, but you're not assigning it inside the ledgers. You have their nullifiers set inside of the map, and you're calling them that way with ZSwap and receives. So yeah, client-generated IDs for orders and fields, historical multi trees for append only and commitments, per key maps and sets for ownership and nullifiers. So straight up conclusion, don't queue everyone behind a shared number or root. This is really important. Okay, usability boost. This is a really important thing that must be taken into account. In plain English, a transaction has a guaranteed part and a failable part. The guaranteed must succeed. Failable segments can fail without invalidating the whole transactions. Why this matters? You can bundle multiple contract calls into one transaction while still isolating optional or riskier steps. So, for example, you could have your failable executions. So you have a contract call that might fail. You can always send it inside the failable. So that means you'll have a partial success. So if you must always have a concurrent, so like you have a really important circuit migrated to concurrent safe objects and practices, but you want to have, you cannot avoid to have a failable part, have the synchronous parts that will only work once. So you do it this way. You have guaranteed in concurrent safe and failable in concurrent unsafe, or however you want it to go. This is like it explains. So idea: build small single-purpose circuits, improve them in parallel, then assemble them into one transaction. Pattern guarantees shipment. Fees plus must succeed actions. Fees must always be added inside guaranteed, because otherwise that's not okay. They'll fail. The transaction will not go because of the fees. So yeah. Failable segment, as I've said, optional calls, extra fields, best effort. The result would be a faster UX, a faster parallel proofing, and cleaner failure handling per segment of the transaction. Okay, this is an example for concurrent order creation. You create an order, you have the order ID, you have the order object, you have the orders stored as a map. You just assert and insert, and that's straight up succeeding. User bring their own unique order ID. So that means order ID must be done, order ID observation for this contract must be done off-chain. You read the ledger via an indexer, you see which is the next one, and you insert it. That works. Concurrent deposits. Basically, many users can append their commitments at once. Commitment insertion only. Real deposits also claim ZSwap coin inputs. So the ZSwap layer is basically the zero knowledge swap layer where the coin inputs and outputs are processed. So, for example, this is a balance tree. You have a historic Merkle tree. And how does this work? You deposit, you insert the hash. This is directly the commitment. So this is how a concurrent deposit would work in a DEX design, to have multiple deposits going in the same block. Commitments and pre-image. Why is this safe? Plain English, basically the chain stores the hash, not the private data, and only the owner can rebuild it. So this basically, it's really, really safe. It's not private, and that's good. And this is the small code snippet. So yeah, the flow. Deposit, you basically deposit, then you commit and insert. Spend, recompute, prove. Invalidate, disclose, nullifier. This is how it goes. I'm not really going to go exactly into this because it will take some time. So why do we do this? Commitments plus nullifiers are public, they're on-chain. Pre-images stay private, and basically the historic roots are keeping the proofs valid inside of your contract, and you reconstruct it from your commitment node, and after that you spend it by receiving them inside of the contract call execution. And that's how it works. So you're not storing them inside the ledger, you're storing them inside the historic Merkle root. So basically they're assigned somewhere in the blockchain, but not directly inside of the contract. So you don't have your usual qualified coin info with it's a Merkle tree index with its type, with its color. Those are not there. You just have a commitment, which is basically this hash in the balance tree. So a bit complicated, I know, but for who works with concurrency safe applications, I guess I gave you some powerful inspiration. And yeah, here we have the balance node, we have the order, we have the change. This is the most powerful flow you actually can do. So you spend a private balance node to create an order and get change. And you're not revealing the balance or the owner. So this is basically UTXO style spend plus change with privacy and concurrency. So what since we talked about Cardano, what Cardano does with batchers and with batchers, yeah, we can do this in Midnight directly in a smart contract. So this is how it should go. So yeah, but it's really, really complex. So I guess I won't bore more. So yeah, how reconstruction works. Only the owner of the commitment can actually do that. So for example, you have in your state the commitment, the nullifier, the disclose fields, and the tree root inside the Merkle tree that I showed before. The private part that stays inside of the blockchain, which no one knows, is actually the full pre-image and the nonce. This is owner only, so this is never disclosed. This keeps basically executions as private as it can be. So how does this actually reconstruct? The owner reconstructs, you basically do the commit, you do the persistent commit, and you get the pre-image and the nonce in the contract call. So this proves the membership against the historic root that you stored in the ledger. You disclose then a nullifier derived from the same pre-image. So as a procedure, even if some fields are disclosed, for example, the token, the amount, you still cannot reconstruct the private pre-image without the nonce. So that's like your secret key, which allows private execution. Yeah, so how do you spend or invalidate? So you're trying to rebuild the commitment and prove it was in the tree. You have the witnesses, which are the private ones, which anyone that executes the contract must give. So yeah, you have a secret node and a secret nonce. This is how you spend. You have a Merkle tree digest, which is the root, and then you have the path, which is the Merkle tree path. You get the node, you get the run, which is basically the nonce. You get, as I said before, the persistent commit with the node, with node and rand, and then you assert that it's in the tree. So that means you have it in the contract. You're the owner of said token balance. So this is how it goes. I know, pretty complex. It goes a bit beyond the usual increments and moving inside data set structures, but this is how Midnight actually stores data and process it with Merkle trees, with nullifiers, with nonsense. Spending in validation. We basically are revealing one-time fingerprint to prevent double spend. So you invalidate it with the nullifier, as I told before. So this is the nullifier. You have a persistent hash of the node and the nonce. You assert it's already been it's not already been spent, and then you nullify it and insert it. That's basically been spent and goodbye. It no longer can be double spent. You don't have these issues. So yeah, the same pre-image cannot be used twice. So the proofs are built off-chain and you're done. Historic roots and re-verification. All this is what I told earlier with the historic proofs, that stale proofs can be basically still used. It's not really stale, but this is how they're described. They are just older and they are not at the current execution. So for example, they were proven 20 blocks before, but they work in our case. So when you're trying to withdraw, you can balance tree. So this is the historic tree that I told before. You can check the root of it, you disclose the root, and this is correct. If it doesn't work, if your root which you're sending is not correct, it will throw a bad root. This is just an assert. And here you just verify commit membership via path. So as I showed you before, not so complex after you have this key dynamic and mechanism in place. As a takeaway, multiple users can prove against the same earlier root. So that's really, really useful when you're doing flows of execution. So some people started executing it at point A, but the chain has moved to point B, but they started the proofing at point A. What happens with their proofs? They must still be valid. So you must take this into consideration, because for really large circuits, let's say you have a K19, a K20, only the proving will take 2 minutes, but the chain has gone far and beyond the point where you started your action. So yeah, validity depends on the tree's history window, so you can reset history. Indexer visibility. So this basically concludes, which I told before, the index is only what was disclosed or stored publicly. This is basically the ledger and what is with disclosed contract address, entry points, disclosed values in transcript, public states, map set trees, counters, routes. So whatever you have as a public ledger can be decoded. What can actually not be decoded is the witness value and pre-images, balances, fields, and details stored only as commitments. This is the fully private contract that I described before. So yeah, as a precision, disclosed data is necessary but not sufficient. You need to actually reconstruct the private intent. Indexer visibility in a practical way. You can index commitments and nullifiers and not private pre-images. As a practical way, you can derive limited facts from a state differentiator. So for example, you have state A at block 200 and state B at block 201, and you can derive that from that part. So yeah, you have it here. Like it's an example. You had the contract action at the contract state, and those change. So in plain English, the indexer gives you the public state and the disclosed values only. So as an evidence note, this is really important. These rules are empirical. They come from our testnet runs and saved results. So what I'm explaining at the moment is available on the preview Alpha 6 version. So yeah, in the future, it might have some differences, but for now, this is how it works. In the future, if anything changes, we're going to update our presentation and our GitHub repository with the tests and with the cheat sheets and with the explanations. So yeah, takeaway, you can treat them as verified behavior, not as a formal spec guaranteed. These do not come from Midnight. These came from our no-seed testing. So while we can vet them, for now, in the future versions, we'll need to come with updates from our side. How we tested this as a testing methodology. We tested on our own preview nodes, so it's the same as the preview Midnight. We're just running in our local environment, so it's more stable. So we deployed some test contracts with counter, map, set, and Merkle. I'm going to show you the contracts later. We generated parallel proofs, so basically multiple contract executions from multiple loaded wallet CDKs. So we did that against the same indexer state in an asynchronous way. Then we submitted the proven transaction all at the same time. Then what did we do? Basically observe success and failure in the same block. So as a result, we have consistent behavior. Read binds, write scales. So you should treat a read operation as a terminal and fixed operation against a block. So what you non-technical guys should remember, you should read sharded state. So for example, this is I'm talking about in the context of our DEX. which is a running order book, a sharded order book. So when you're reading the sharded state, it makes you wait in line, and writing without reading scales. If you're creating orders at different keys, you're basically doing it at different lanes. So that's fine. You can do it however many times you want. And historic keys, historic trees keep more lanes open. So this is as a highway, more lanes open, multiple people can actually use the contracts at the same time. So as a developer checklist, a quick checklist: avoid counter reading hot paths, prefer client generated ID, use historic multi data, keep map sets beyond user order IDs or any part that can be. So basically, yeah, keep it keyed by the user and order ID. So basically, they come from outside of the contract. That keeps it concurrent safe. And use disclose only when you intend to reveal. So if you're doing anything inside of a contract that you don't want to reveal, it's not stored in the ledger, don't use disclose. It will be visible on chain.
Yeah, that's quite.
So yeah.
Yeah, thank you so much. That's quite interesting. I think we've learned quite a lot. Can you hear me? Sorry, Vlad. Yeah, I just wanted to check in. Yeah. Please go ahead. Continue.
So this is the last slide, and then I'm going to close the PDF.
Oh,
so
okay.
Where does this fit in our architecture? So inside of a DEX order book, you map by order ID, it's concurrent. The nullifiers are set by the nullifier, it's concurrent. Balances and fields with historic Merkle trees are concurrent.
Yeah.
Stat counters are write only, so that's safe. And the presentation was useful for developers at Midnight.
It was fantastic. It was fantastic. Yeah, it was fantastic. Thank you so much for that. But I have something to confirm. Like, do you have a GitHub repo or something that you can share in case anyone wants to see any example? If you do have, or if you don't have right away, then you can share.
Yeah.
You can share on the Discord chats or stuff like that. But if you have right away,
so
please share.
We have a Discord. We have a Discord chat. It's our NoC official Discord. We also have a repository, which is noc/io. You just search as an organization.
Yeah, I mean the one related to. Sorry. I mean the one related to like the midnight concurrency, like this particular.
Oh, yeah. I'm going to share it after this meeting. It's still not. Yeah.
Okay.
I'm going to share it after this meeting in our dev chat inside of Midnight. It's better because I think the Midnight builders will be there. So I'll just plug it in.
Yeah, exactly.
So yeah, it's still not public. It's private because we kept adding and modifying some stuff. But I think we have a V1 that I presented to you guys. So I'm going to give it there.
Yeah, it doesn't have to be full blown. It could just be a representation of like just an example representation of what you presented. It doesn't have to be like your actual implementation. If that is still private, maybe you can create a very small definitive.
It's not
like
private.
version.
I'll share all the contracts that actually help you. So I didn't have. I guess we don't have time to also share that, but we have 6 smart contracts that are done for testing this. You have all the goals or the tests, all the results there. You also have. There are basically some node projects. With package JSONs. You just and then you compile the contracts, and then you basically just execute them against a network of your choice. So
I think that's quite helpful. You can feel free to share on the Discord. Then after that, if anybody is interested in looking at it, they can go through and see how the implementation is done. We often like to see more and more use cases, and then seeing how developers like yourself are building out different use cases, particularly with Compact, understanding when to use what, how to use them, and then which one is best fit for a particular use case. So thank you so much. Thank you once again for that. That's a wonderful presentation. All right, everyone, that's a wrap for today. Fireside Hang. Thank you. Big thanks to Steph, Jay, and also Vlad for your contribution today. And thanks to all of you for showing up and being part of this community. Keep building, keep contributing, and we will see you all in the